Hey everyone! Welcome back to ZoomInData. And this is episode 11 of our KQL Concepts Deep Dive series. Today we are exploring filtering predicate pushdown and its theoretical optimization power in KQL. We are keeping everything pure concepts and interview focused. If you missed episode 10 on projection philosophy, it's a great one to review. Let's get started. Here is our roadmap for today. Predicate pushdown moves filters earlier in the query execution plan. Early filtering reduces data volume before expensive operations. Columnar storage enables efficient predicate pushdown. The optimizer automatically pushes where clauses as early as possible. Predicate pushdown is a core optimization technique in KQL. Understanding pushdown helps explain why KQL performs well on large datasets. And this topic appears frequently in performance and optimization interviews. Let's dive into the details. Let's start with what predicate pushdown actually is. A predicate is a filter condition in the where clause. Pushdown means moving the predicate earlier in the execution pipeline. Early pushdown filters data before joins, aggregations, or projections. This reduces the amount of data processed in downstream operators. Predicate pushdown is a standard optimization in columnar databases. It's one of the main reasons KQL can stay fast on petabyte-scale data. Now let's see how predicate pushdown works in KQL. The KQL optimizer analyzes the query and reorders operations. Filters are pushed before expensive operators whenever possible. Columnar storage allows reading only columns needed for the filter. Extents with no matching rows are pruned early. Early filtering combines with lazy evaluation for maximum efficiency. The optimizer does this automatically. You write the query naturally, and KQL makes it fast behind the scenes. Look at this before and after diagram. It shows the real power of predicate pushdown in KQL. On the left is the original flow. Summarize first, then where, then project. Notice the data volume icons. It starts big and stays big through the expensive summarize. Lots of unnecessary rows get processed. Now look at the right side, the optimized flow. The optimizer pushes the where filter early, before summarize. See the funnel icons shrinking the data right away. Much less data hits the heavy summarize and project steps. The big arrow in the middle says predicate pushdown. That's KQL's optimizer moving your filter as early as possible to cut out junk rows before they waste time and resources. This is why a simple where clause on billions of rows can still run in seconds. Early filtering plus columnar magic equals massive speed. The benefits of predicate pushdown are huge. It reduces I/O by skipping irrelevant data and extents. It lowers memory usage by filtering before aggregations. It improves CPU efficiency by avoiding work on filtered out rows. It enables faster query execution on large-scale datasets. It combines with columnar storage for 10 to 100x performance gains. This is why you can write a simple where clause on a billion-row table and still get sub-second results. Pushdown does not always happen perfectly. Pushdown is limited when filters depend on computed columns. Complex expressions or user-defined functions may block pushdown. Joins can restrict how far predicates can be pushed. Materialized views and some plugins limit optimizer freedom. Always test performance when pushdown is blocked. Knowing these cases helps you write queries that let the optimizer do its best work. Check out these two side-by-side scenarios. They show when predicate pushdown works great and when it gets blocked. On the left is good pushdown. The where filter comes early, before the heavy summarize. See the funnel icons. Data shrinks dramatically right away. Way fewer rows hit the expensive aggregation. Fast, efficient, perfect. Now swing to the right. Blocked pushdown. The filter is after a computed column or join. Look at the warning icon. Optimizer blocked. The filter can't move earlier, so data stays large through the costly steps. Less shrinking, more work. Performance takes a hit. The key takeaway: write filters early and avoid complex expressions or joins before them. That lets the optimizer push predicates down hard and keep queries blazing fast on big data. Why does this topic matter in interviews? Interviewers ask about optimization techniques in KQL. Common questions include, what is predicate pushdown? And how does KQL optimize filters? Understanding pushdown shows knowledge of performance internals. This topic is key for roles involving large-scale querying and tuning. Explaining pushdown demonstrates deep understanding of columnar engines. It's one of those concepts that separates good KQL users from great ones. To wrap up, predicate pushdown moves filters earlier in the execution plan. Early filtering reduces data processed in expensive operations. KQL optimizer automatically pushes predicates when possible. Columnar storage and lazy evaluation amplify pushdown benefits. Pushdown is a core reason for KQL's performance on big data. Master this concept, and you will understand why KQL feels so fast even on massive datasets. That's episode 11 done. Thanks for spending time with me on ZoomInData. Next in episode 12, String Search Semantics, we will explore tokenization, contains versus has versus tilde versus regex, and how to choose the right one. Homework to lock this in. Explain to someone or out loud. What is predicate pushdown and why is it powerful? Think of a query where early filtering makes a big difference. Answer this one. Why does columnar storage help predicate pushdown? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 12, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.